Good morning, everybody. Today we are going to continue on with some organic stuff, but today it's going to get a little fancy. So, if you've been following with me this week, essentially the first 2 days here I introduced some simple concepts of organic molecules. We looked at simple examples yesterday involving all having three carbons in them and using the different functional groups. So there's a couple things that we need to do. We need to be able to identify the functional groups, which really matters, and that takes time. Obviously, it's been a while. If you have the old sheet or if you have it open in a different tab today, that's going to help immensely because I'm not really going to be referencing it in terms of going back to it in my video here, but I'm going to be like referencing it in my words and in my identification of what we're looking at. So today is more like actually naming organic molecules, and this is can get pretty tricky. We'll start slow, of course, but there's quite a bit going on, and it's once you get the hang of it, it is kind of fun. It's kind of puzzly. It's kind of enjoyable. So anyway, so here's the extended rules for naming organic molecules. First things first, we need to identify what's called the parent chain. The parent chain is just the longest consecutive chain of carbons. So when we're looking at our molecules, most of the time it's very obvious. But later in this sheet, with the different shapes that we're making, it can be very tough to identify it, and we'll be numbering our carbon chains as we go along. Identify all the functional groups. That's going to be off of yesterday's sheet. So when we see an OH, we know it's an alcohol. When we see a double E bonded O in the middle of a chain, then we know it's a ketone, things like that. So that'll take a lot of practice, and you are going to have to kind of reference the old sheet from yesterday. It'll help a lot. Number 3, number the carbons in the parent chain from one end to the other so that the side groups have the lowest set of possible numbers assigned to them. We'll go over that, and then there's some tiebreakers in the next sentence that we'll talk about when we hit those two. Number 4, if the same functional group shows up more than once, you use prefixes like di, tri, and tetra. So for example, if there's two OH groups on one carbon chain, that would be a di-all, meaning like two alcohols. If there's more than one functional group on a molecule, they get named in alphabetical order. And then you ignore the prefixes in that. So again, there'll be examples of all of these as we go along. Number 6, if there is two chains of carbon with equal length in your structure, the parent chain is selected based upon the chain which has more functional groups on it. So if the way this carbon chain branches, there's two equal lengths, we use the one that has more things on it or more functional groups on it. And if there's still a tie, then we use the one that gives us the lowest set of numbers. Number 7, if you have a cyclic molecule, meaning like a ring of carbons, you use the prefix cyclo and it appears directly behind, or directly in front of the base name, I should say. All right, so let's give it a shot. So here's our first molecule. And again, when we look at organic molecules, they typically don't even draw the carbons in, and they very rarely draw the hydrogens in because the hydrogen is just kind of implied. So I have in this molecule 1, 2, 3, 4 carbons. So the prefix for 4 carbons is bute. And again, that's off of yesterday's sheet if you're looking for that. So this is going to be something with the prefix bute. We need to identify the functional group here. So this is an OH, that's an alcohol. So we could call this butanol. But here's the problem. If I just say butanol, I don't know whether that oxygen and hydrogen, that OH, I don't know whether that's attached to this carbon or whether it's attached to this carbon or this one or this one. So we also need we need like a numbering system to kind of identify where that hydroxide shows up, right? So this is where numbering these carbons comes in. So this is carbon number 1, that is carbon number 2, that's carbon number 3, and that's carbon number 4. You can number them starting at either end, but the idea here is that you number them so that the functional group has the lowest possible number that it could have. So I could do 1, 2, 3, 4 like I did, and the alcohol is on carbon 2, or I could have done it 1, 2, 3, 4 backwards, and then the alcohol group would have been on carbon 3. So 2 is lower, that's the way we want it. So instead of calling this just butanol, we're going to call it 2-butanol, and that's the appropriate name for this molecule. So again, you identify how long the chain is and figure out what prefix that would be. Look for the functional group. Number your chain so that the functional group gets the lowest possible number, and then you name it. 2 is implying the carbon the alcohol group is attached to. All right, let's try another one. So our parent chain here, 1, 2, 3, 4, 5 carbons. That's the prefix pent. And this is a doubly bonded oxygen. And we have 2 functional groups with doubly bonded oxygens, or I actually have more than that, but we have 2 with just a double bonded oxygen, right? So in this one, the double bonded oxygen's in the middle of the chain, so this is a ketone. If it were on the end of a chain, that's called an aldehyde, and they get identified separately, even though they're really kind of the same thing, right? It's just a double bonded oxygen somewhere on the carbon chain. But this is a ketone. So we could call this pentanone. And again, the way we end this name, it starts with pentane. For 5 carbons, you cut off the E of pentane and replace it with one. Okay, and that's in the previous sheet as well, if you're looking for that somewhere on your notes. And then we identify where the ketone is. So we could number these carbons in one of 2 ways. I can go 1, 2, 3, 4, 5, or I can reverse that and go the opposite way. And we want the number to be the smallest, right? So the best way to do that is like this. We want 1, 2, 3, 4, 5, like such. So then this becomes 2-pentanone, and that's our answer. The next one. Now we're up to 1, 2, 3, 4, 5, 6, 7 carbons. That's the prefix hept. So we would start with heptane, but we have a double bond. So this is now an alkene. So we can fix the name, right? The ending of an alkene, gets named ene. So we're going to call this heptene. But we need to identify where the double bond is. So again, we can identify it. If we just call this heptene, it could be here, it could be here, it could be here, it could be anywhere within this chain, and it's not specific enough. So now we need the number. I can go 1, 2, 3, 4, 5, 6, 7, or I can go 1, 2, 3, 4, 5, 6, 7. The number of your double bond gets numbered with the first carbon that it hits, meaning when I number from left to right, I go 1, 2, 3, and we'd use the number 3 because that's the first carbon that the double bond shows up on. So 3 is obviously going to be less than 4, and our name here should be 3-heptene. This one is a little sneaky, and the reason why it's sneaky is because they're showing 90-degree bond angles right here around this triple bond, and there should be, right? So when you have 2 carbons with a triple bond, it is going to be linear. So there's no kind of bend or angle on opposite sides of those triple bond, but there are carbons there. So really this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So we're going to start with the prefix non, and the only functional group we have is this triple bond. That's called an alkyne, and all we do is switch the ending. So we're going to start with nonine, but again, we need to number and identify where that triple bond shows up in our chain. So we're going to number left to right, obviously, because it's going to be much closer to the lower numbers on the left side. So 1, 2, 3. And we're going to call this 3-nonine. Next, now we have an aldehyde. We have 1, 2, 3, 4 carbons, prefix is bute. We can number them from right to left because then this shows up on carbon number 1. When a functional group shows up on carbon number 1, you don't need a number. So an organic molecule without a number for the functional group implies that that functional group is on carbon number 1. So this is going to be bute. And again, with an aldehyde, the way we switch the ending is we drop the E. So what would normally be butane, drop the E, so it's butan. And then for an aldehyde, we use al. So butanal is the correct answer. And there's no need for a number because, again, without a number, it's implying that it's on the first carbon, which it means it's on the end of a chain. Plus, in reality, it's an aldehyde, right? So aldehydes sort of imply it's on the end of a chain anyway because that's where the double bond oxygen needs to be. All right, a hexagon. That's geometry. This has 1, 2, 3, 4, 5, 6 carbons, which would be hexane. There's no double bonds, no triple bonds, no other anything. This is just carbons and hydrogens. Again, the hydrogens are all hidden, but they're there. So if it's a ring, all we need to do is use the prefix cyclo. Cyclohexane. That's it. Really, really easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is just called decane. Ooh, tougher functional group here. This is an ester, so we have 1, 2 on the left, 1, 2 on the right. With an ester, we have to think about how to name this thing. So I'm actually going to go back for this one because this one's a little more complicated. And I want to make sure we get it right, and I want to make sure we revisit it. So with esters and ethers, it's a little more difficult because we have to name two chunks of carbon chains, right? So we have 2 carbons and 2 carbons. So if it loads, hey, there it is. Let me find the appropriate spot. There we go. So with an ester, okay, the side with the double bonded oxygen gets named first, and its prefix gets a YL ending. So we would call this ethyl. The side with the double bonded oxygen gets named, oh, I'm sorry, without, ha ha ha, let's try that. My bad. So this side gets named first, my bad. So that's called ethyl. And then the side with the double bonded oxygen gets named next, and we use the prefix, use the appropriate prefix and replace the E and ane with O8. So it's going to be something O8. So ethyl, and this is also 2 carbons, so that's F. And O8. So ethyl ethanoate is the appropriate name for this ester. And again, esters and ethers are a little tougher because there's just, you gotta name both sides and it makes it a little bit more difficult. But all right, this is one functional group. Again, it kind of looks like it maybe wants to be 2, but when you have a double bonded oxygen and an OH at the end of a carbon chain, that's actually what's called a carboxylic acid. So it's its own individual functional group. We have 1, 2, 3, 4, 5, 6 carbons, and this is going to be called hex. Ane, or that's where we would start. We would drop the E, and it turns into hexanoic acid. And now we have an amine, a nitrogen at the end. So I have 1, 2, 3, 4, 5, 6, 7, 8. This would be octyl amine. This is an amide. I have 1, 2, 3, 4, 5 carbons, and this turns into pentan amide. This is another, this is an ether. So now again, we need to name both sides. In an ether, we name both sides and we use the YL ending for both of them, and we just do it in alphabetical order. So I have 2 carbons here, that'd be F. I have 3 carbons here, that'd be prop. So this is going to turn into ethyl, propyl, ether. This is now more difficult. So what we need to do first in this molecule is we need to identify the parent chain. Because you notice that we have carbons kind of branching off in different directions. So we need to identify the longest consecutive chain of carbons. So I can go 1, 2, 3, 4, 5, 6. I can go 1, 2, 3, 4, 5, 6. I can go 1, 2, 3, 4, 5, 6. There's 3 different ways to get a chain of 6. The next tiebreaker between that is the one with the most functional groups. So I can go 1, 2, 3, 4, 5, 6, and I get one functional group, this guy hanging off over here, and a second functional group, this guy hanging off over here. Or if I go 1, 2, 3, 4, 5, 6 around like the hook here, I only get one functional group. This chunk of carbons hanging off this chain is just one individual functional group. So we want the chain with more than one functional group, or the most functional groups. So we're going to number this 1, 2, 3, 4, 5, 6, or reverse, right? We could name it 1, 2, 3, 4, 5, 6. Depends upon whether we get lower numbers one way or the other. And it doesn't matter whether I call this my last carbon in that chain or this my last carbon in that chain, because either way I have a single methyl group hanging off of that second carbon, if you kind of can see that. This is a difficult one, or well, we're getting more difficult, I should say. So I'm going to call this 1. I'm going to call this 2, 3, 4, oh, come on, there we go, 5, oops, that's not a 5, and 6. All right, and now it's hexane, right? 6 is hexane, but I have a 1 carbon off of my second on that chain, and I have a 2 carbon chunk off of the third of that chain. So this is a methyl group for 1 carbon. This is an ethyl group for the third carbon. So we're going to call this hexane, but we need to identify both those pieces. And we name them in alphabetical order because there's 2 functional groups. So I'm going to name the ethyl one first, and I'm going to call this 3-ethyl 2-methyl hexane. And that's the appropriate name for this molecule. All right, now we got another one with 2 functional groups. I have 1, 2, 3, 4, 5, and I have a choice. I can go one way or the other. I'm going to go 6, 7. So this is something hept with the prefix 7. And now I have 2 functional groups. I have a ketone here, and I have a methyl group here. So I can name this as 1, 2, 3, 4, 5, so 3 and 5, or I can go 1, 2, 3, 4, 5. Ooh, it's 3, 5 either way we name it. So now we want to go in alphabetical order. So we have a methyl group and we have a ketone group. So we want to number, oh, I'm sorry, I think I'm saying the wrong tiebreaker for this one, my bad. So we want to number it where, let's go back. Come on, there it is. So we want to number it so that the parent, well, let's see if we can find it. So if you get the same set of numbers, either way you do it, the lower number should be assigned to the functional group that is part of the parent name, or the one that comes first alphabetically. So in this one, we have 2 functional groups. We have methyl, and we have a ketone. Now the ketone is going to be part of the parent name, because what I mean by that is it gets that suffix, right? The anone at the end of that molecule name. So this is going to be heptanone. So that is part of the parent chain. We want this one to have the lower number. So we're going to call this 1, 2, 3, 4, 5, 6, 7 as our chain. And I'm going to name the methyl first, because the ketone is just part of the parent name, so it's not really an alphabetical tiebreaker. The ketone just is going to be a part of the name. So I'm going to call this 5-methyl 3-heptanone. And that should be the appropriate name. We have 2 alcohol groups, carbon chain of 1, 2, 3, 4, 5. So this is pent. And this would be 2, 4, pentadiol. So the N gets dropped when we have that prefix. Don't lose too much sleep over that. If you called this pentanediol, that would be perfectly fine. I wouldn't give you points off by any means. But the appropriate name is 2,4-pentadiol. And this is the first time we've seen a prefix with a functional group. So there's 2 alcohols. I number them both. One's on 2, one's on 4. And I just call it a diol. Ooh, now we're having fun. 1, 2, 3, 4, 5, 6, 7, 8, 9. We use the prefix non. I have 2 methyl groups, and I have an alkyne. The alkyne's in the parent chain, and we'll want to number these so that they're as low as possible. I can start here and go 1 for that functional group, 4, 7, 1, 4, 7, or I could go 3, 6, 8. That's not as good. So we're going to go 1, 4, 7. So the 1 is our alkyne. And if it's on a 1, we don't need to include that number at all. It's implied if we just leave it as is. So we're going to name the 2 methyl groups. Those are on carbons 1, 2, 3, 4, 5, 6, 7. So we have 4, 7, dimethyl, because there's 2, 1 on each of those. And then we just call the rest of it as it is. So the rest of it is nonane, with this all single bonds, right? But it's an alkyne, I'm sorry. So we need to switch the ending to non-ine. And we don't need to number the non-ine or identify where that triple bond is because it's on carbon number 1. If it were somewhere else in our chain, then we would have to call this 4,7-dimethyl number non-ine, right? So that, if the triple bond was somewhere in the middle, then we would have to switch and put a number somewhere in this name to identify where that belongs. All right, the next one, 1, 2, 3, 4, 5, 6, 7 carbons. So we have 2 functional groups. I have a carboxylic acid over here, and I have an ethyl group right there. The carboxylic acid group is at the end of a chain, so I think we're going to call that carbon number 1. And the other one's on carbon number 1, or sorry, 1, 2, 3, 4, 5. So this is going to be 5 ethyl. And then we would just name the rest of it as is. 1, 2, 3, 4, 5, 6, 7 in my chain. Heptanoic acid. 5-ethyl heptanoic acid. And that would be the appropriate name. Next, this one's fun. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I think that's my chain right here. So we got this weird carbon chain we're kind of wrapping around, and we got 3 functional groups on this one. We've got an alcohol, which is going to be a part of the parent name. I've got a methyl and an ethyl. So we can number this from left to right, it looks like, because if I start up here, I'm going to get I'm going to get a 3, a 4, and a 5. Whereas if I start right here, I'm going to get a 2, a 3, and a 4. So that's better. So let's start a number. This is my number 1 carbon. 2, 3, 4, 5, 6. So this is something hexanol. Okay. And we would name this in alphabetical order. So F is going to get labeled first. E comes before M for the methyl. So 1, 2, 3. So 3 ethyl, 4 methyl, 2 hexanol. And now we're having fun. So so these side chains, these ethyls and methyls go in alphabetical order. And then last but not least here, we use the alcohol as a part of the parent name, but we have to identify where that is too. So I hope that makes sense. I'm almost done. I'm sorry this is getting very long, but I kind of enjoy it. I know you probably don't, but if you're willing, you can skip it, fast forward. That's fine. So we have another cyclo molecule here. This is cyclohexane again, but I have 3 methyl groups hanging off of it. So this is going to be a trimethyl. I have carbon 1, 3, 5, trimethyl cyclohexane. And again, it doesn't matter which one I call my first carbon because it's all symmetrical, right? So this could be carbon 1, 2, 3, 4, 5. This could be carbon 1, and I could go 1, 2, 3, 4, 5. Either which way you number it, as long as you start with one of those methyls on the first carbon, it's 1, 3, 5. This is an amine, and we have a cyclo chunk over here. This is butane, cyclobutane. So all we're going to do is call this cyclobutyl amine. Pretty easy. We have 2 double bonds. So this is a diene, 2 alkenes in the same molecule. 1, 2, 3, 4, 5, 6, 7. And we're going to start on the left-hand side because that's going to give me a 2 for this double bond and a 4 for that double bond. So we're going to call this 2,4 heptadiene. I hope that makes sense. Again, they're getting kind of weird, but that's okay. This one is really fun. My chain is actually going to be this backbone along the middle here. Whether you believe me or not, you can check it out for yourself, but I promise you this backbone down the horizontal zigzag here is your longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something decane. But now I have 6 functional groups off of here. I've got a single carbon here. I've got 3 carbons there. I've got 3 carbons here. I've got 2 carbons there. I've got 2 carbons there. And I've got another single carbon here. So we're going to go in alphabetical order. I've got ethyl. I've got methyl. I've got propyl. So we start with ethyl. Ethyl is going to be, we're going to number from right to left, I think, right? Because if I number from right to left, I'm going to have on carbon 2, 3, 4, 5, 6, and 9. Whereas if I number from left to right, I'm going to have carbon 2, 5, 6, 7, 8, 9. That's not as good. So we're going to number right to left. So this will be carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll start with the ethyls. This is going to be 3, 4 diethyl. And then it's going to be what? 2, 9 dimethyl. And 1, 2, 3, 4, 5, 5, 6 dipropyl decane. My typing's trying to drop down to a lower line. It's too long. There we go. And that's the appropriate name. I think my face is in the way. Hold on. I can't even like move it. No. Whatever. All right. Anyway, so there you go. I hope you enjoyed this. Have a great day, guys. I've also shared out a little quiz thing. That's your homework for tomorrow. Don't worry about it. You can do on that. You can work on that tomorrow if you've made it this far. I sincerely admire your motivation and dedication to chemistry on May 20th. Have a great day.